Dear students, today we see about the determination of moment of inertia by using the bifilar suspension system. So, for aim of the experiment to determine the mass moment of inertia for bifilar suspension system, apparatus required, a timer and the experimental setup. So, next we are going to see about the tabulation for the experiment. So here this is the tabulation. The first how much weight we going to add in the bar. So that is weight of the bar. Next weight added in the bar, and then distance from the center to weight added, and time taken for one oscillation, length of the rope, and actual mass moment of inertia of the system, and theoretical mass moment of inertia of the system. Next, finally we find the theoretical and actual deviation. So this is the experimental setup for the bifilar suspension system. So this is the rod. So here end we going to add the mass. So next, this is the oscillation. So this oscillation we going to take the one time taken. So now we switch on the timer, and then we going to add two side of the rod to add the mass, and then we going to oscillate the rod. So finally we got the one oscillation for time taken. So we done only first trial. Now we move on the second trial. So first we going to reset the timer and then add the mass on the given setup. So this is the procedure to add the mass for the bar, and next we going to oscillate the bar. So now we taken a time for the one oscillation for the second trial. So same as well as we going to do the third trial also. Third trial we going to add the another 200 grams mass, and then to take the time taken for one oscillation, and we do the calculation. Formula used for the experiment: I theoretical is equal to mg a square t square divided by 4 pi square L. I actual is equal to half into m a square plus h square plus mk square. So this formula we going to use for the moment of inertia actual and theoretical we going to calculate. Next we going to see about the tabulation. So for this tabulation, the first column is weight of the bar. This is the constant value. So the 4.7 kg, 0.47 kg, and weight added in the bar. So this value is trial 1, trial 2 and trial 3 we increase gradually. That means 200 grams, 400 grams and 600 grams. So next, distance from the center to weight added. So this is the center of the bar is here, and then this distance, the center point to the weight added, that is a, small a. So that distance is also constant, 0.75 meter, and then actual mass of inertia of the system. So this value is got from the I actual from the formula, and then theoretical mass moment of inertia of the system. So next, time taken for one oscillation. So we gradually increase the weight. We got the 3 trial value time taken for one oscillation, and then length of the rope. Length of the rope is constant for all the trials, and next we going to calculate the actual mass moment of inertia of the system for given formula, and then theoretical mass moment of inertia of the system for the given formula. So finally we find the deviation for actual and theoretical, and we go for the result. So that's the value of mass moment of inertia of the body with the end weight mass are found out the experiment and compared with the theoretically. So thank you. Dear students, today we see about determination of mass moment of inertia using compound pendulum. So this is the aim of the experiment, to determine the mass moment of inertia by using the compound pendulum. Apparatus required, experimental setup and stopwatch. Next, now we see the block diagram of the compound pendulum. So for this compound pendulum we have the holes in different lengths. So for this holes we going to pivot in a different holes, and we take the time taken for one oscillation. Tabulation. So here we going to take the 5 readings for the compound pendulum. So first one is which hole we going to pivot. Likewise first hole, second hole, likewise. So which hole we going to pivot, and time taken for n oscillation and time taken for one oscillation. We going to convert time taken for one oscillation, and then centroid from the pivot point, and I theoretical, moment of inertia theoretical and actual. So formula used, I actual is equal to 1 by 4 pi square into T into M into G L1 whole square. So this formula we are going to use for the I actual. Next, I theoretical M divided by 12 whole square plus B square plus M into I1. This formula used for the I theoretical. So next we are going to do the experiment. So now we do the experiment. So for this experiment we have the compound pendulum in different length holes. So first hole we are going to pivot. For this hole we are going to take the time taken for 10 oscillation. For 10 oscillation by using the stopwatch. After 10 oscillation we are going to take the reading and we note it down, and we move on the second hole. So for this hole we are going to same procedure we are going to follow. So we take the 10 oscillation for a time taken, so converted to the one oscillation. So this is the second hole. So this reading also we are going to taken, and then third hole. So here also we do the same procedure. For 10 oscillation we are going to take the reading. So next, fourth hole we are going to take the 10 oscillation reading. So next, fifth hole. This is the last one. We take the 5 readings. Okay, these 10 oscillations readings we converted into the one oscillation, and then finally we done a model calculation, and finally we got the I actual and I theoretical. So we taken all the readings. Now we going to see the model calculation. So hole number 1 we got the 10 oscillation means 6.5 oscillations we taken. So now we see about the model tabulation and calculation. So for this tabulation, hole number 1, here they are taken the 5 oscillation, 5 time taken for 5 oscillation 6.3 seconds, and then one oscillation we going to convert into one oscillation 1.26, So next one, that center from the first point, that is 25 mm, and then I theoretical we got the 0.102 kilogram meter square, and then I actual 0.31435 kilogram per meter square. So we done a one trial for the to find the I theoretical and I actual, moment of inertia actual and I theoretical. So we followed this procedure same for five trials, and finally we got the comparison between the moment of inertia for I actual and I theoretical. So next we go for the result. Thus the time taken for oscillation found out for the given compound pendulum, and moment of inertia can be calculated and verified with the theoretical value. Thank you.